Okay, I want to highlight on the shear force diagram and bending moment diagram, how to draw the shear force and bending moment diagram using end moment that we get from moment distribution method. Okay, so I have done this before. So I have checked using Excel, and the moment is like this. This is for AB, AB, BA, BC, CB, CD, and DC. Okay, and this is the diagram. AB, no external load. BC, 100 kilonewton at the center of BC and 25 kilonewton per meter along member CD. Okay, if we need to draw the diagram directly from end moment value, okay, what we need to do is we just have to refer to the moment direction because moment rotates. So AB is positive, so rotates positive direction. BA positive direction. So for the moment value, so this is the point and the point. So what we need to do is we just need to join this dot. So we get the bending moment diagram for member AB. For member BC and CB, since moment rotate positive, negative and positive, so means that this is the point. Okay, start from 0 and end at 0. However, since along on member BC there is a point load 100 kilonewton, so there is a maximum moment here that we can only get the value from shear force diagram. However, if we just want to draw the shape of bending moment diagram, we may also draw just like this. Okay, so it is negative 65.2 and negative 146.8. It is negative because when we plus back with this one, okay, this one is positive, right? This one is positive because this negative, this one is negative, plus with this one which is positive, so we get back to 0 because we must close the diagram. Okay, so same goes to CD based on moment, moment rotates, so CD is negative, DC is positive, so the point in the diagram is like this and like this. Okay, start from 0 and at 0. UDL means maybe it has maximum moment. Okay, and the value we can only determine from shear force diagram. So the last value is negative and negative in the diagram because we must plus back with positive here so that we get back to 0. Okay, I want to show how we analyze how we want to analyze the maximum moment at member BC and member CD. So we analyze member BC. It is just like we analyze simply supported beam. Okay, simply supported beam. Okay, this is the free body diagram for member BC itself. So this free body diagram actually have been discussed in chapter 11 under slope deflection method. Okay, so this is the section. Okay, this is the free body diagram. So moment negative and positive we get from table, right? Negative 65.2 and positive 146.8. Okay, so there shear force at B and C, BY2 and CY1. So we need to determine the value of shear force. So we get C1, CY1 is 58.16 and BY2 is 41.84. So using this value, we draw shear force diagram. Again, we must start the diagram from 0. It is 0 plus 41.84. We go straight until we meet 100. We minus 100, we get negative 41.84. Go straight until we meet another point load. It is negative 58.16 plus 58.16, so we get back to 0. So this is the shear force diagram. Okay, using the area of shear force diagram, we can draw the bending moment diagram. Okay, the start must be 0. It is 0 plus negative 65.2. We get this point. Okay, so negative 65.2 we must plus with this area. Okay, negative 65.2 plus area of this one, the area of this, it is 41.84 times 5, so we get 144. So 144, we continue with minus this area. Okay, this area minus this, so it is 144 positive minus 5 times 58.16, so we will get this point. It is 146.8 negative. So this negative, this one is negative because we must plus back with positive moment 146.8, so that we get back to 0. So this is the bending moment diagram for member BC. Okay, now we analyze member CD. We do the same. We analyze member CD. CD is like this. It is UDL. Okay, shear force like this. It is CY2 and DY. Moment is, the moment is negative positive, negative and positive. Okay, the moment is 146.8, 146.8 and 126.6, 126.6. Length is 8 meter. UDL is 25. Okay, so we have to analyze this using static equilibrium. We have to analyze this to determine CY2 and DY value. So by taking moment at C is equal to 0, it is negative 146.8 plus 126.6 plus 25 times 8 times 2 minus 8 dy is equal to 0. So we calculate this and we get dy is equal to, it is negative 146.8 plus 126.6 plus 25 times 8 times 2, times 4. 25 times 8 times 4. Okay, divide by 8. So it is 97.475. Okay, check back. Negative 146.8 plus 126.6 plus 25 times 8 for P and length is 4, divide by 8. It is 97.475. Okay, so CY2 is, it is 25 times 8 minus 25.8 is force, so we minus with 97.475. It is 102.525. So this is the shear value for member CD. So it is 102.525 and 97.475. UDL is 25 times 8. Moment is 146.8 and 126.6. Okay, now we want to draw shear force diagram. Okay, shear force diagram. Okay, 0, then go up 102.525. So 102.525 we minus with 25 times 8, we get negative 97.475 here. Okay, plus back with this negative, this one is negative, right? 97.475 plus this one is positive, plus this one, we get back to 0. So we just have to join this dot like this. So we get here is positive, negative. Okay, now we want to check the length for this triangular. It is, since shear force, this is in kilonewton, and here length must be in meter. So it is kilonewton divided by kilonewton per meter to get the meter unit, the unit meter. So it is equal to 102.525 divided by 25. So this is 4.101, and the other one is 97.475 divided by 25. So we get 3.899. So total is 8. Total is 8. So using the shear force, we can draw the bending moment diagram. Okay, the first moment value is negative 146.8. 146.8 here. 146.8. Okay, it is negative. So the diagram start with 0. 0 minus 0 plus with negative 146.8 is negative here. Negative 146.8. Okay, we need to plus with this area. So negative 146.8 plus 0.5 times 102.525 times 4.101. So we get 63 point. Okay, this is located at the intersection. 63.428 4275. Okay, minus with this triangular, minus with this, minus 0.5 times 3.899 times 97.475. Okay, from calculation we get negative 126.6, negative 126.6, somewhere here it is 126.6. We get negative because here because this is negative, because when we plus back with this one, because this is positive, so we get back to 0. So it is like this. So this is positive like this. So this is the, okay, this one is shear force diagram, and this one is bending moment diagram. Remember that the diagram must always start with 0. Start with 0. It is 0 plus negative 146.8. Okay, plus the area of rectangular, of triangular. We get here, this point, positive 63.428. We minus this positive, okay, positive 63.428 minus the second triangular, we get negative 126.6. We get negative here, plus with the moment we get from table is positive, because we need to close the loop like this. Okay, it is like this. So this is BMD. Okay, I hope this example will help you all to draw the shear force diagram and bending moment diagram. Okay, you may try the other example. Okay, and I wish you good luck. Thank you very much. Assalamualaikum.